Hello viewers, this is Wagda Ronald taking you through the tutorial of vertical motion under gravity lesson 2. In the previous lesson we saw the equations of vertical motion under gravity, and these were that for downward motion the equations will be this, so G will be positive, but for upward motion A will be negative G. So the equations will be that. So there are two kinds of motion: downward motion and upward motion under gravity. Today we are going to look at this problem. A stone is thrown vertically upwards from the ground with a velocity of 25 meters per second. Find part A, the maximum height it attained; part B, the time taken to reach maximum point; then part C, the time taken by the stone to return to its point of projection; part D, the velocity of the stone as it hits the ground; and lastly, the time that elapses before it's at a height of 20 meters. So we shall start with part A, which is the maximum height it attained. Now this will be our sketch. It was projected with a velocity of 25 meters per second. This particle will move upwards until a point B where it is momentarily at rest, and at this point its velocity will be 0. From that point, beyond this point, the particle will now move vertically downwards and will hit the ground with a velocity V. So from A to B, that height is known as the maximum height, and that's what we want to get. So we shall consider motion AB. For motion AB, initial velocity will be 25, vertical velocity will be 0, and the height moved will be the displacement. That means we shall use third equation of motion, whereby initial vertical final velocity is 0, initial velocity is 25, then G is 9.8, and S will be our H max. So when you make H max the subject, we shall come up with this and use the calculator to get 31.8878 meters. So that's the height they wanted. For part B, they wanted the time taken to reach maximum point. So now we know the initial velocity. For considering motion AB, we know the initial velocity and final velocity. That means we can use the first equation, whereby final velocity is 0, initial velocity is 25, G is 9.8, and T is what we want. So making T the subject gives this, which can be calculated to get 2.5510 seconds. So that will be the time they wanted. Part C, the time taken by the stone to return to its point of projection. In other words, this stone has to move from here through B and back to the point of projection. So we shall consider motion ABC. If you consider that motion, you realize that the displacement is 0. Why? Because it returned to its point of projection. Therefore, we shall use the second equation of motion, whereby displacement is 0, initial velocity is 25, which is this, G is 9.8, and T is that which we want. So substituting using a calculator, we can simplify this to get 4.9, so that we come up with a quadratic. Then we factorize T is common, so factorizing it out gives this in brackets. That means either T is 0 or T is 5.1020. But T cannot be 0. Why? Because at T equal to 0, it was at this point of projection. Now, therefore, T will be equal to 5.1020. That is at this point after moving through B. So that's the time they wanted for it to return to its point of projection. Part D, find the velocity of the stone as it hits the ground. So as it hits the ground, they want this velocity. So we shall consider motion from B to C. From B to C, it means that initial velocity is this, which is 0. final velocity is v, which you want, and the displacement is h max. So substituting final velocity is what you want, initial velocity is 0, g is 9.8, and s is our h max, which is 31.8878. So using a calculator, we shall come up with this value, 25 meters per second. So you should know that that value is the same as the initial. We shall see why. Then part E, the time that elapses before it's at a height of 20 meters. Before it's at a height of 20 meters. In this case, they want the time taken to move from A up to this point where the height is 20. Then also the time taken to move from A through that point through B up to here. So there are two times which they want. So the time taken to move from here up to here, and the time taken to move from here through B up to this point. So even you can see that in both cases, at this point and at this point, the displacement is the same, 20. So we shall use second equation of motion, whereby s is 20, positive because it's above the point of projection. Initial velocity is 25, t is what we want, g is 9.8. So when you substitute, you shall get a quadratic equation in terms of t. Make the t squared positive, we shall get that. Then when you solve this quadratic equation, we shall get 1t being equal to 4.11 seconds, and the second t will be equal to 0.99 seconds. So what does that mean? It's at a height of 20 meters after 0.99 seconds while moving upwards, and after 4.11 seconds while moving downwards. So at this point is moving upwards, at this point is moving downwards. So those are the two times they wanted. Now there's points you need to note. One, when the particle returns to its point of projection, the total time taken for the motion is equal to twice the time taken to reach maximum height. Think, compare those two times, you'll realize that one is twice the other. Then furthermore, the initial and final velocity are equal in magnitude but opposite in direction. This implies that at the 2 points, when the particle is at the same height from the ground, the velocities are equal in magnitude but opposite in direction. That is why you realize that the velocity at this point was the same velocity at this point. Why? They are the same displacement. Same displacement from the initial point of projection. So that has been our lesson 2. Tune in next time for lesson 3. Thank you for watching. Subscribe my channel.